So here is the 2019 Higher Paper 1, question 11. This question focuses on integration with limits. Now we need to make sure we remember how to integrate simple terms, how to integrate sine and cos, and we have to make sure we understand the difference between a definite and an indefinite integral. And we have to be able to express both effectively and accurately. Now this one having limits means it's a definite integral. We're going to get a numerical solution at the end rather than some sort of solution where it's a function plus c. So in order to do this one, what we do is we integrate this, then we take the function that we get when we've integrated at the upper limit, take away the function we get at the lower limit. So if I take the integral, just focus on this bit here to begin with, of cos 3x, what I know is that that is going to equal the integral of the cos x, which is sine. That's going to be sine of 3x minus pi by 6. But it's then divided by the derivative of the function in here. Derivative of this is 3, so it's going to be 1/3. And I know that that is then going to be between my two limits of 0 and pi over 9. Now that I have that, what I'm able to do is take this function at the upper limit and subtract the function from the lower limit as well. So I'm going to do 1/3, and what I'm going to do is just keep that out the bracket. It's going to have the same effect no matter what, of sine of 3 times pi over 9, take away pi over 6, minus sine of 3 times 0 minus pi over 6. So what I can then say is, fine, that's going to be 1/3 times, well, sine of 3 pi over 9, take away pi over 6. So 3 pi over 9, that's the equivalent of pi over 3. So I've then got pi over 3, take away pi over 6. So 2 pi over 6, take away pi over 6. So that will then give me sine of pi by 6. And then going to be take away, so sine of 0 minus pi over 6, so sine of negative pi by 6. However, sine of negative pi by 6 is the equivalent of negative sine pi by 6. So it's going to be sine pi by 6 take away negative sine pi by 6. So what that then is going to mean is I've got 2/3 times sine of pi over 6. Now because it's a non-calculator paper, we'd be expected to remember what sine pi over 6 is. Just remember your wee exact values triangle. So you'd have a little triangle like this, your right angle triangle. Now this angle here, if it was in degrees, would be 30 degrees, or pi over 6 if it was in radians. This one here would be 60 degrees, or pi over 6 if it was in, pi over 3, sorry, if it was in radians. What I know is the side opposite 30 would be 1, opposite the 60 is root 3, and here is 2. So this little triangle here helps me to remember my exact values. So sine pi over 6, sine is saw in SOHCAHTOA, opposite over hypotenuse. So for pi over 6, sine of pi over 6 is opposite over hypotenuse, so 1/2. So that's going to be the equivalent of 2/3 times 1/2, which is going to be simply 1/3. So there you go. The integral between those two limits is equal to 1/3. So for this kind of question, we had to remember what the integral of our trig function was. We had to then remember the integral using the chain rule. We then had to remember how to use our limits, but also some of our exact values. Make sure you remember these exact values. You've got this triangle here, or you've got the one which focuses on being 45 degrees in both of the corners there. Now obviously 45 degrees is pi over 4 as well, so it could be in radians. In this one, the sides opposite the angles are both 1, and you've got your root 2 there. So this will help you remember sine, cos or tan of 45 degrees. These two triangles are fairly straightforward to remember. Just commit them to memory if you can't remember the exact value straight away off the top of your head. They'll help you and make sure you can answer a non-calculator question which will focus on this. This question here was worth 4 marks. So first, for starting your integration and getting the sine part. Second, remember in your chain rule and getting the 1/3. Third part for knowing to substitute in the limits and starting it. Final mark, final answer of a third. So there you go, nice 4-mark question based on integration. Hopefully something that we can find fairly straightforward and be able to walk away with a score from.